Hello and welcome back to Tip Ice. In this video, we are going to show you how a spectrometer is used during a batch reaction to keep track of the concentration of the red dye within the batch reactor. So in this example here, we are going to have two cuvettes, one for each of the two spectrometers. These are filled with 50% volume percent of sodium hypochlorite. The sodium hypochlorite is a 8 times 10 to the negative third molar concentration, in which we'll be putting this red dye, which is 8 times 10 to the negative fifth molar, into the reaction. And then over time, this red dye, as you will see here in a little bit, will slowly decrease as it reacts with the sodium hypochlorite. So as you can see on both sides, you have the 50% volume of the sodium hypochlorite with another 50% volume of the red dye, in which we shake it up a little bit and we put it into our spectrometers. On this right hand side, I just did a third um, batch reactor just to kind of show you and a visual representation of what is going on inside the cuvette, inside these spectrometers. As you can see here, both of them tend to start on the higher end. So more of it is being absorbed because of the concentration of the red dye being very high. Now as the red dye reacts with the sodium hypochlorite, it will dissolve and basically disappear. And as you can see on both spectrometers, you can see the absorbance or the voltage decreasing over time. This is, like I said, due to the sodium hypochlorite reacting with the red dye. Now, as we go through this, you can see it is kind of hard to tell, but the red dye, that red cuvette, is slowly decreasing in concentration over time. So as we skip ahead here a little bit, in both of these videos, you can see that the voltage and the absorbance continually decrease as the sodium hypochlorite reacts with that red dye. Continue on a little bit more. That continues to decrease. As you can see, that cuvette right there, it is a lot more clear than before. So on this left-hand side, we pull it out. You can see that it looks very clear compared to what it started at when it was the fully concentrated red dye. As we go back over here and continue to look at this spectrometer, you can see that it actually looks pretty clear, and you can actually see the reason it looks red is due to the reflection of the red light coming from the spectrometer. And here in just a second, I'll pull the other one out and I'll turn off that light to then show how the red dye is totally dissolved in the sodium hypochlorite. So as you look at both of them here, you can see that they both look pretty clear, and as we turn off the red light, you can see that the red dye has completely dissolved within the sodium hypochlorite. As we pull up the absorbance of this concentrations, you can see the blue is the industrial spectrometer and the orange is my spectrometer. In absorbance, you can see that the blue has a higher curve compared to the orange. This is much like in the previous video in which the concentration for the industrial spectrometer the absorbance for the industrial spectrometer is actually a lot more narrow of a gap due to the voltages that the industrial spectrometer could read. Hence why it appears to be a more straight downward curve compared to mine, which seems to be more of a straight line going horizontal. They are both going down. You can see the voltages here, and then you can also see the absorbance here over time. So as I said before, a spectrometer is a good way to calculate the concentration of an unknown substance. And in this purpose, you can use it for a batch reactor. You can see how over time the batch reaction occurs and how the concentration of the red dye decreases, much like a normal reactor would occur. And these are just a few videos of how a spectrometer is used in industry and how you can use a spectrometer to calculate the concentration. We thank you for your time and we wish you a great day.